A conspiracy theory is an explanation of an event or several events, which typically invokes a sinister plan by a secretive group of people. Secrecy plays a key role in these explanations, and conspiracy theories often involve some sort of secret or exclusive knowledge that only a select few are privy to. Conspiracy theories often fly in the face of conventional narratives or contradict the consensus of established experts whom they believe are quote-unquote hiding or covering up the truth. Conspiracy theories generally fall into distinct categories: political, historical, scientific, or supernatural. In the following video, myself and a group of my friends will cover different examples of conspiracy theories that we've come across on social media and offer our brief rebuttals to these ideas. So the first conspiracy theory I want to respond to is a classic one, and that is the city of Atlantis, specifically the idea that there was once this lost continent, this lost civilization that had a major influence on world history and has been lost to time. And sometimes we get into this concept that this history is being kept secret from the rest of the public by some sinister group of academics or historians or archaeologists. Now, the origins of the story of Atlantis goes all the way back to the Greek philosopher Plato. In his two books, the Timaeus and the Critias, he gives an account of a city that was once at war with the city-state of Athens called Atlantis. And in both of these accounts, Plato will provide a description of the city of Atlantis, including its structure, system of government, and some general features about the civilization as a whole. I'm going to be showing you a clip here of a conversation between Graham Hancock and Michael Shermer, in which they're debating how exactly we should be interpreting Plato's account of Atlantis. So let's take a look.
And I know that you're a staunch opponent of Atlantis and that you believe Plato made Atlantis up in order to make a political point, and you may be right, but the date that Plato puts on the submergence of Atlantis is 11,600 years ago, 9,000 years before the time of Solon, which happens to coincide with Meltwater Pulse 1b and the end of the Younger Dryas, which I would have thought would cause you to rethink your position on Plato just a little.
Well, it's interesting. I'm open to the idea. I tend to read myths in the same way your guest Jordan Peterson does. That, you know, it's a story to deliver some sort of moral homily to us. It's a commentary on our own culture, our society. It's a literary way of delivering a message to people. That's how I tend to read. Instead of reading them like, let's see if we can figure out what happened historically.
But there's hard data in Plato's whatever you think it is, and that hard data is that the submergence of Atlantis happened 9,000 years before the time of Solon.
So the debate here between Shermer and Hancock hinges around how exactly we are to interpret Plato's dialogues. Shermer is here taking up the conventional position supported by academics and Plato scholars, which is that Plato's account of the city of Atlantis is to be read and interpreted largely as a myth, that we see examples of myths Plato utilizes throughout his other writings. This is something that Plato is known to do. If you see, for example, Plato's Republic, we have the example of several different now famous myths. The Republic is probably Plato's most famous work. We see in it, for example, the myth of the Ring of Gyges, the allegory of the cave, and Plato is known to use myth throughout his work to prove and to demonstrate, to illustrate larger philosophical concepts that he's trying to get across to his audience. Now, why would he do such a thing? Why would he use myth in that sort of way? The answer to that question is that the Greek educational system, we're talking about the ancient Greek educational system, was deeply rooted within mythology, within epic poetry. We know, even from Plato's dialogues, that people like Socrates and other ancient Athenians, in their education, in the schooling that they got as children, they were taught the poems of Homer and Hesiod. They were taught these ancient myths. And these myths were used for a variety of reasons. One of the biggest reasons was that these myths were used to convey moral or life lessons. Plato will refer to Greek myths throughout his works, and oftentimes we will see Plato creating his own myths to demonstrate and illustrate his own points. Now, the trinity of Greek philosophy pictured here, Socrates, Plato, Aristotle, these are all historical figures. Socrates was the teacher of Plato, Plato was the teacher of Aristotle, and this lineage is important, going back to what Schirmer said, because the standard interpretation is that Socrates himself never wrote anything, that what we know about Socrates comes fully from Plato. Now, Plato's work, Plato was a very prolific author, can be divided into kind of three distinct categories. This is the standard academic interpretation, the early, middle, and the late dialogues. And it's generally assumed that in Plato's early writing, which is largely about the life, trial, and death of Socrates, that Plato is more or less giving us the spirit of Socrates. Now, all of Plato's writing comes in the form of dialogues, that is, conversations between characters. For example, in Plato's Euthyphro, we have a conversation between Socrates and the priest Euthyphro. In Plato's Apology, we have Socrates being on trial, and we have a conversation between Socrates and people that are involved in the Athenian legal system that are charged him with various crimes. And it's generally assumed that in the early dialogues, when we hear Socrates talking, we're not getting a transcript of word for word of what Socrates is saying, but rather we're getting a general sense of what Socrates was like and his specific teaching style, what has later become known as the Socratic method. Whereas in the middle and the later dialogues, we get a much, if you compare and contrast the Socrates of the Symposium with the Socrates of the Apology, there's two slightly different characters. And so the thought process here by scholars is that in the early dialogues is a closer representation of who the historical Socrates was like. And in the later dialogues, we get more of Socrates as the mouthpiece of Plato. So part of the confusing part with this conspiracy theory and this argument that both Hancock and Schirmer are having is that a lot of this stuff is attributed to Plato without much reference to the specific genre that Plato was writing in, specifically the genre of the dialogue. Nevertheless, we have this claim by Hancock that we ought to be interpreting Plato, that we should be taking him at his word. Now, Schirmer disagrees with this because, like most other Plato scholars and most other ancient historians, academics, and archaeologists, it's largely assumed that the point of Plato's dialogue is to make these larger philosophical points, and that Plato really isn't interested in recording history proper, at least as how we would think of history. Hancock disagrees with that, and the reason for his disagreement, as he expresses in the video, is that the timeline that Plato gives in the Critias corresponds with what he calls the Younger Dryas, that this is a concrete date that we can pinpoint, and that as a result, we ought to take what Plato is saying here as relaying some historical truth, specifically about this lost civilization of Atlantis. Now, Hancock is correct in how he is portraying the presentation of the information that is relayed in Plato's dialogue. So let's take a little bit look at the claims that are being made here by Hancock and kind of what that's based in. So these are some selections from the Critias. The Critias involves the main interlocutor, Critias, who is having this conversation with Socrates. And in the dialogue, Critias is going to relay what his relatives or what his ancestors had told him. And this is supposedly information that has been passed down from Solon, from this original Egyptian source. Now, I want to be very clear in that the earliest account of Atlantis that we have is explicitly from Plato. And the idea that Solon visited Egypt and that Solon received information about Atlantis from Egypt, that there has not been a single Egyptian source about Atlantis that has ever been verified by any academic, archaeologist, or historian whatsoever. That the only account that we have of Atlantis comes from Plato. But this is what Critias says in the dialogue. Let me begin by observing, first of all, that 9,000 was the sum of the years which had elapsed since the war which was said to have taken place between those who dwelt outside the Pillars of Hercules and those who dwelt within them. This war I am going to describe. One of the combatants on this side was the city of Athens, was reported to have been the leader and to have fought out the war. The combatants on the other side were commanded by the kings of Atlantis. which I was saying was an island greater in extent than Libya and Asia, and then afterwards sunk by an earthquake and became an impassable barrier of mud to voyagers sailing from hence into any part of the ocean. Now, the Pillar of Hercules would have been a geographical feature that Plato's audience would have been familiar with. So we're talking about ancient Greece, specifically the city of Athens, which is here-ish. No one call me out on that. But Greece, of course, is a part of the Mediterranean world, the Pillars of Hercules being this narrow strait that's between modern-day Spain and Morocco, leading out into the Atlantic Ocean. Plato's giving us a theoretical geographical location of Atlantis, which is beyond the Pillars of Hercules, and that it was a pretty significantly sized island, the size of Libya and Asia. And when Plato says Asia, he's talking about like modern-day Turkey, what they called Asia Minor. Now, Hancock's argument is that we can take this account seriously because the date that 9,000 years ago, before the time of Solon, that Plato provides corresponds with the Younger Dryas, corresponds with an actual geological event, and that therefore this indicates to us that Plato was in some way telling the truth. Now, this is a difficult claim, of course, because there's no physical artifacts that were left behind from the city of Atlantis. We don't have any archaeological evidence. We don't have any ruins to explore, nothing that we can date anything by. And so Hancock is founding his argument on the claim that the time for the supposed war that's taken place between Athens and Atlantis is taking place at roughly the same time as the Younger Dryas, and that this might explain how the city of Atlantis is submerged, and that this gives us a kind of a concrete timeline, and that as a result, we should believe that what Plato's saying here is an actual recounting of a historical event. Now, the major objection to this claim is that although we don't have anything that we can concretely date Atlantis by, we don't have any archaeological evidence that we can use for dating, there is another city that's mentioned in this story that we have a ton of archaeological evidence concerning, and that's the city of Athens. Because in the Critias, Plato says that Atlantis and Athens were founded, existed, and went to war with each other at roughly the same time. So theoretically, if we are to interpret this historically, at least if we are to give what Plato is saying historical value, then we ought to verify that in some way, shape, or form with the archaeological evidence we do have about the city of Athens, and that this would give us insight into which interpretation is correct. Is Plato telling us a myth here, or is he giving us actual concrete history? As I mentioned before, there's actually a tremendous amount of archaeological evidence regarding the ancient city of Athens. So the earliest evidence that we have of human settlement around the city of Athens actually comes from the cave of schist, in which we see human occupation inhabitants from roughly the 11th through the 7th millennium BCE. Now, when I say human occupation, I'm talking about maybe large families, groups of a dozen to a few hundred humans, but we're still talking largely of nomadic to semi-nomadic people that are moving in and out of the region, probably following various types of food sources. It's not until around 3000 BCE that we get the establishment of the city of Athens, of ancient Athens as we know it in the literature, and that Plato himself would have been familiar with. The Acropolis, the building, as you see pictured here, dating from roughly that time period, was initially set up as a Mycenaean palace, and the earliest archaeological evidence of building sites is what we're dating to about 3000 BCE. But even then, it's not really until about 1400 BCE that we get the city of Athens establishing itself as any significant sort of power within the region with a standing army and navy. And that's not until the Mycenaean civilization, again, roughly around 1400 BCE. So with the available archaeological evidence that we have, the earliest that we can really date the city of Athens in terms of any concrete structures being built is about 3000 BCE. The Younger Dryas, which Grant Hancock references repeatedly in the video, doesn't start to occur between 12,000 and 11,000 years ago. So the timeline that's being used here is dramatically off. So going based purely on Hancock's criteria for the interpretation of Plato, do we interpret this as a historical event? Yes, because it corresponds with a geological time period. Okay, but what does the archaeological evidence tell us about the city of Athens? The historical site itself we can date to about 3000 BCE, which is, of course, about 8,000 years after the Younger Dryas period. So again, we go back to those two interpretations. Do we interpret this as a myth that Plato is using to demonstrate a larger political or philosophical point? Or do we take this as Plato recounting actual historical events? Well, it's clear, based off of the evidence that we have, that this can't be referring to historical events, so we're left with the mythological interpretation. All Plato scholars would agree the city of Atlantis is a myth that Plato's using in his writing to demonstrate a larger political/philosophical point. It is not meant to be interpreted as a historical site or place.
Hey everyone, I am going to be responding today for the first time. This is the first time I'm ever making any content that isn't just me appearing on somebody else's stream. So yeah, finally doing that. I don't know if I'll ever do it ever again. But I decided to make a video responding to Nathan, aka Pitch Lumen, who is a flat earther who I know has had some discussions with Mark Reed, so you can go and check those out. And specifically, we're going to be talking today about gravity and atmospheric density and how those things are related to each other.
Claim is, and then what actually happens. And so here you have the Earth with the gas molecules here. You have a gradient, which is having very high density towards the surface. And then as you go further out, the gradient gets less and less according to the globe. Here you have plus level 10.
So I want to highlight what he just said. He said that the gradient gets less and less. What I presume he means by that is that the air gets thinner, the pressure gets lower. You have fewer molecules of air in a given volume as you go up in altitude. I don't think that that's unique, as far as I know, to the globe model. I'm pretty sure flat earthers also acknowledge that air gets thinner as you increase in altitude. Your ears pop on planes or even on sufficiently long elevator rides in some buildings. So I don't think that that's specific to the globe model.
Call it gravity, and as you go further out, you get weaker and weaker gravity, or we'll call this minus sign level 1, and it is next to a strong vacuum. So,
and strong vacuum, he means a very, very pure vacuum or a high vacuum. Strong, weak, high vacuum, low vacuum. It's one of those words where, because you're talking about how pure of an absence there is, it's a little tricky. But he means very, very, very few particles in the given space.
Gravity can hold the atmosphere to the Earth. That's the claim. Gravity can hold all of the densities of atmosphere to the surface, including this layer, so including the most dense layer. What would be happening here? So using the Earth's gravity at plus strength, you're holding this density to the Earth as well as all of these other densities.
Yeah, so the sort of pivot to density is a very common thing that is done by people who are I don't want to use the word skeptical because I don't think it's actual skepticism, but people who do not believe in gravity in the way it is typically understood as being a universal thing which attracts all massive objects to all other massive objects according to, most of the time, to a good enough approximation, the Newton's law of gravity, for example. That's fine. I think where he's going is pretty clear, I think, here.
With weaker gravity. And
that's true. The gravity at the edge of the atmosphere would be weaker than the gravity at, for example, sea level, because you're further away, and because the gravitational force falls off as 1 over r squared, where r is the distance from your source of mass.
This is kind of a cleaner drawing to depict the surface of the Earth with the plus level gravity, holding the most dense layer of gravity to the Earth using plus again. And we'll just say this is gravity within 100 feet using atmosphere within 100 feet. So G within 100 feet holds the densest layer of atmosphere. Now, if you set up experiments where you have 1 equal to, or density level 1, or 1 density level of marked by 1, you have the same density marked by 2. It's the same density, and you keep G equal to G, which is what you would be doing. You'd be using that plus gravity. And you would be holding.
This part is a little bit muddled, but he is making a coherent point here, and it's one which intuitively makes a fair amount of sense. I will give him full credit for that. It's why I'm responding to this video. Also, because I think Nathan seems like a pretty nice guy, honestly.
Holding the same level of atmosphere, or same density of atmosphere, so you have the same density should be held with the same gravity. And so then you would run this in a lab. You would have a weaker vacuum because we cannot make a vacuum as strong as outer space.
Not technically true. The vacuum in the vacuum chamber in my experiment at work is actually such a high vacuum, such a strong vacuum, as it were, that it's on the same order or potentially even a higher vacuum than if you were to open the door on the International Space Station. There are some kinds of experiments in my line of work. I'm an experimental atomic physicist specializing in ultracold atoms. There are some experiments where you need the pressure to be so low that if you were to open the door on the International Space Station and do your experiment out there, it would be too high. There would be too much pressure, gas pressure, atmospheric pressure outside the International Space Station to do some of these experiments, which require very, very long lifetimes for the trapped gases that we use.
And you would put a box of density 2 of atmosphere, which is equal to the most dense layer within 100 feet of the surface. And actually, because we would be doing this experiment on Earth, this box would be subject to plus level gravity, level 10 gravity, because you're at the surface of the Earth doing this experiment. So you would actually get the Earth to provide the constant of gravity, therefore G equals G.
So the idea is, the basic argument here is, okay, the gravity is capable of holding atmosphere on Earth according to the globe model, which I agree with. Therefore, if we take a chunk of atmosphere and were to put it in a vacuum chamber and release it, if gravity is so strong, it should all stay down there, and it should just sort of fall and maybe spread around the bottom of the chamber instead of expanding to fill the chamber. That's basically the claim, and it is a coherent claim.
So the conclusion is that, or the possible options is that you can have gas 1 is claimed to be held at G, therefore gas 2 should be held at G. That is the conclusion that the globe makes.
No, it is not. No, it is not, Nathan. There are other factors here that are important. The reason a gas expands to fill a volume typically is because the atoms and molecules in the gas have a high kinetic energy, and they're zooming all over the place, and they're zooming around fast enough that they're just going to keep on zooming up, and they don't really care so much what direction is gravity. In normal air, the density of air is high enough that a molecule will only travel maybe a few dozen nanometers or something. I don't know the precise number before it hits another one. But if you just had one atom and you didn't have all the rest of them, that one atom is just going to go flying, and it's going to fall down. It's going to fall down, and I think you agree that it's going to fall down. And if you don't, then I would very much be interested in knowing that. But you claim that the globe model predicts that the gas will expand to fill that vacuum chamber. Now, if you take a little chunk of air and you put it in there at like you put a little, I don't know, like a capsule or jar of air, and then you put it in a vacuum chamber, and then you broke the jar, and it was normal, standard temperature and pressure air, then yeah, it's gonna expand to fill the vacuum chamber. Or will it? Depends on how big your vacuum chamber is in that case. Because if your vacuum chamber was 300 miles tall, 3,000 miles tall, is it going to expand to fill that entire thing? How many of those atoms are going to make it all the way to the very top of that box, of that vacuum chamber. It depends on how hot the gas is. The reason the gas, all of the molecules go and zip around is because they have so much energy, because they're at like room temperature. Now, as you go higher and higher and higher, you get the atmosphere changes in its temperature as you go up and up, and we can have that conversation. There are some subtleties that are going on there, but a lot of those atoms, they're just not going to be energetic enough to escape, even if you heat them up to 1,000 degrees, because Earth has a lot of gravity. It'll go up, but eventually it'll start falling down. The other question is, what if it's just a normal size box? Okay? Can you take a gas and put it in there and release it inside that vacuum and have it not expand to fill the vacuum? Well, yes, you can if the box is big enough. You also can if the gas is cold enough. So if you cool down your gas, if you make those atoms really, really, really cold and therefore moving really, really, really slowly, then yeah, all the atoms are kind of moving around a little bit. But when you release them, you stop holding them there, they're not going to expand and fill the entire thing. They're going to expand slowly and fall. And we can do that experiment. And we do that experiment. And I have done that experiment. It's how I calibrate the magnification of my camera in my experiment. I release a cold gas of atoms and they fall, and I know how fast they're falling because things fall at a certain rate here on Earth, at a certain acceleration. And I use that to get a quick measurement for what my camera's magnification is. Those atoms, when they hit the bottom, they just stick to it because they're very cold, and the chemical bonds that they form when they hit the bottom of the chamber, just leave them there. You can take pictures of this gas as it falls. You can shine a laser on it. The laser is how we get them to get so cold in the first place. It's a very interesting technology, actually. We can do this experiment, and I don't think it necessarily goes the way you expect it to. The other thing that we can do, which is related, not exactly what the point that you're raising here, is we can hold a gas. You can hold it right next to a vacuum without a physical material container, without a container made out of atoms and molecules. You have to do things to hold it. You need to have some phenomena, some force that's keeping them in. And in our case, it's a combination of magnetic fields and lasers. But in the case of the Earth, it's gravity. In the center of our vacuum chamber, we have a gas, and the pressure in that gas, the density of that gas, is not zero. Whereas a little bit further away, just at another spot in our vacuum chamber, that the pressure is real close to zero. It is many tens of thousands of times less dense than this isolated cloud in the middle that we trap there. This has been done for decades now. And so the question of what would your lab experiment actually show? Would it show what you expect? I don't think so. That's more or less everything that I wanted to cover in this video. And I might go into more depth at a later time. I would love, by the way, to have a conversation with you, Nathan. I think this is really cool. I love talking about physics, and I could show you. I could take you on like a video tour or something of my lab and show you some of these experiments and how it is that we cool down gases and trap them inside, trap a local cloud of gas inside a vacuum chamber, and then we drop them and watch them fall. Because it's really cool stuff, and that's why I love what I do. Thanks.
Thank you everyone for watching, and a very special shout out to Michael van de Graaff for his contributions to this video and his explanation of some pretty complex topics in physics. If you're interested in Michael and the things that he has to say, although he does not have his own channel, there are a few places on YouTube where you will be able to find more of his content. For one, you can check out the video interview that I did with him on my channel titled On Physics. Michael is also a regular guest on Maya Akeson's channel in a regular show that she features every Sunday called Bad Science Sunday, if you would like to see more of him there. Thank you again for watching. I hope that you appreciate the content. Please feel free to leave any replies, any questions, or objections to anything that was stated in these videos below in the comments. Until next time.